Okay, so once you have poured it, right, and then allowed for cooling, right, so that it can solidify. And as I said, the cooling time will depend on all these factors: thickness of the part, thickness of the mold, and the material used, right? Mold thickness also, because the part inside the molten metal will solidify, it will give out the heat to the mold. The mold will give out the heat to the surroundings, right? That's how the heat transfer will take place. So it depends even on the thickness of the mold and the material, of course, thermal conductivity. So you see, and then casting removal. After the molten metal has cooled, the mold can be broken and the casting removed, right? The ceramic mold is typically broken using water jets, but several other methods exist. Once removed, the parts are separated from the gating system by either sawing or cold breaking using liquid nitrogen. So basically, you'll have to remove the gating system, right? So either sawing or cold breaking, that is basically liquid nitrogen is used to have that separation of the required casting and the gating system. And then finishing. So finishing. Oftentimes, finishing operations such as grinding or sandblasting are used, right? Sandblasting is basically uh, you allow the sand to you give the sand a higher velocity, right? Basically, just as you uh, give velocity to water, right? So you can have cleaning of any of your regular component, right? I mean, in our everyday life. So sandblasting is also one kind of finishing technique, right? Just so that we can have the proper surface finish. Heat treatment is also sometimes used to harden the final part. Okay, you see on that what we have seen. We came to this diagram and then we went there, right? So I hope the process is now clear. What do you mean by investment casting and what is the, so this image is the gist of the process. Okay, the reason why I kept this image is this is the gist of the process. If you just remember what is happening here, if you remember these 10 steps, basically 9 actually, you can write it, right? If at all it is asked, right? When it is asked, you can write. Is it clear? Okay. You see another uh, example. You have this. This is the casting that you want. Okay, individual. So what we are doing is we are going to putting multiple wax patterns, right? You see wax gating system. All these are wax patterns. Ceramic shell, because this is that ceramic slurry. We dip it multiple times, drying in between, and then once that is heated and the wax patterns are melted, you pour the molten metal, right? And then in the end, finish casting, you remove that, right? Water jets or shaking, etc. You can remove that. You have the individual component, and all this will be counted as byproduct, right? So that can be remelted. So the reason why I did not put only this is because it is missing a lot of steps, right? That heating and all those steps, heating of that pattern so that it can be removed, the wax can be removed, but still, you see advantages. It can form complex shapes and fine details. There are many material options, as I said. Many materials could be formed with investment casting. High strength parts, you get high strength parts with this kind of method. Okay, very good surface finish and accuracy. So little need for secondary machining, as I said. So you will have a very good surface finish and accuracy because of that surface finish of the ceramic slurry, right? That mold, you will have good surface finish. Disadvantages: It's time consuming process. You have to wait until for every other step here, right? You have to firstly make it here in this mold, and then dip it, wait for it to dry, again dip it, right? Place it in the oven. So quite a long process. So time consuming, high labor cost. Tooling cost is also high, as you can see that mold is also required firstly to make that wax pattern, right? The slurry is required, and what else? Wax pattern would cost you, right? Tooling cost, long lead time possible, right? Uh, Applications, turbine blades, armament parts, pipe fittings, lock parts, hand tools, jewelry. You see, jewelry industry is one of the most uh, significant sector that uses this investment casting, right? Because we have a lot of complicated details, minute details that are required on jewelry. So investment casting is the way out. You see here, these are the parts manufactured by investment casting. As I was talking about turbine blades, right? You see these kind of blades and even these kind of blades. So, and all these parts, you can see the complicated features on them. All these are possible when it comes to investment casting. So that wax pattern, if you are able to make it and you're able to dip it in the slurry, and the rest of the process is simple, right? So that wax pattern has to replicate your desired casting, isn't it? All these are parts manufactured by investment casting. Video, let us have a video tomorrow, right? In the next class, we will see a video about all these processes at once, right? Just so we can compare, right? We'll have a basically an overview, right? A bird's eye view. We'll see all processes at once, hopefully. You see properties and considerations when going for investment casting. Classes of extremely complex parts, as I was talking about, right? With good surface finish. If you are considering complex parts and good surface finish, this is one option, investment casting, right? Another thing is very thin sections, right? To give you an idea, 0.4 mm also, right? It's possible. Thin sections of 0.4 mm dimensions are also possible. They have been manufactured using investment casting. It also allows for high dimensional accuracy. Tolerance is as low as how much? 0.076 mm. I'm reading out only mm because that's what we follow in India, right? So even those tolerance range have been claimed with this kind of process. So that control is there if it is required, as it is required, right? In turbine blades, aerospace industry and defense industry requires these kind of tolerances to be maintained. Practically any metal can be investment cast. Parts manufactured by this process are generally small, but weighing up to 75 pounds is basically how much? 37 or something, right? 37 have even been made, right? Some part of the investment process may be automated, right? Even this is possible. Automation is also possible. There's some parts, right? As for example, that die, injection die, right? Injection molding. This can be automated. Even this can be automated. This dipping of the slurry, etc. But wherein high, this molten metal, etc., this has to be taken care, right? By manually has to be taken care. So that and investment is a complicated process and is relatively expensive, right? This is expensive because of the long steps and the tooling and the pattern required, isn't it? So it's quite an expensive because that injection molding die will be expensive. That is the most expensive part, we can say, to be able to make that die with all those features that are required, because the features in the die, in the inside of the die, will be the features that is required on the casting. So more the complicated features, more is the amount of design detail required in that die. So that makes it expensive. Doubts so far? Okay. You see, as for applications, as I said, aerospace and power generation industries to produce turbine blades with complex shapes or cooling systems. Blades produced by investment casting can include single crystal, directionally solidified or conventionally equiax blades also, right? I even talked about direction solidification, right? So that will, the properties of the casting depends on how it's solidified, right? The grain structure. So if you are able to manipulate the grain structure, right, with directional solidification, then that is a very good achievement, and that is required. Directional solidification will get you some properties, right, which are enhanced, and those are required for strength purposes. So those can be done. Investment gas is also widely used by firearm manufacturers to fabricate firearm receivers, triggers, hammers, and other precision parts at low cost. So precision parts is what you can make, right? All these precision parts. Other industries, military, medical, commercial, and automotive. Medical in the sense, presently 3D printing is being used, right? But in the past, I believe this was being used for this precision and complicated parts, right? Automotive, we have even discussed some examples, right? Is it clear? Investment casting. Um, 19H55110, Haripriya. 19H55110, Haripriya. Are you in the class? Are you listening? Not listening. 18H51199. 18H51199. Not listening. 157, Nikhila. 157. Not listening. So if there are no doubts, then we'll end the class.